All right, let's look at one just quick video here, a little bit more about applications of the ellipse. And we know that the distance from one focus to any point on the ellipse to the other focus is the same no matter where we are. But I want to take a look at a different relationship that happens with that. And what I'm going to do is I'm going to put a point on the ellipse. Okay, and I'm going to create what we call a tangent line, a line that's going to intersect the ellipse only at this point C. So I'm going to come here, I'm going to choose tangents, I'm going to select the ellipse, and I'm going to click this point, and there's a tangent point. So no matter where this point is on the ellipse, it only intersects the ellipse in one point. And that's because we're going to see what happens when we reflect off of this point. So let's say that we send something out from this point right here to bounce off the ellipse at point C. Well, to bounce off something means we're reflecting off of it. And it's hard to understand how something reflects off a curved surface if you don't understand what tangents are. So when it reflects off this point C, it's actually like we reflect off this line. And you go back to geometry, whenever we did reflections with respect to line, not curves. So if we put this tangent line in, when we reflect off the tangent line, it's going to send us in the same path that when we reflect off of this point on the curve. So here's the big moment, right? So let's send a line from there to there. Let's see if we can't. Yeah, there we go. So wherever this point is, okay, we've just sent something from B to the point C, and now it's going to reflect off of it. So I'm going to go to my reflection tool, and I'm going to choose to take this line that we just sent and reflect it off the tangent line and look and see where it goes. It goes to the other focus, doesn't it? Okay, that's really cool. Okay, so no matter where we reflect off the ellipse, as long as we started from the first focus, okay, and we send it out to the ellipse, it's always going to reflect back to the other focus. And this is a really, really cool property about ellipses as well. And a couple applications here of that would be, first one would be a whispering room. I think you've probably seen that in another YouTube video that I posted. You're going to have a couple problems about whispering rooms. But imagine we're standing in a room that has a domed ceiling. Okay, the ceiling is in the shape of, well, a cross section of it would be an ellipse. If you rotate it to actually make like a full three-dimensional dome from an ellipse, it'd be called an elliptoid. So let's imagine that the dome is an elliptoid. It's a three-dimensional ellipse. Let's say the x-axis is the floor. Well, if you stand right here and you just whisper, if you're at the focus and whisper, the person at the other focus can hear you even though they're a long distance away, because that sound is going to travel perfectly from you off the ellipse and right there. And the cool thing is, the sound that travels from your whisper to this point reflects there, but also the sound from your whisper from this point is going to come in this direction. It's going to bounce off. Every sound that comes from you is going to reflect off the ellipse from whatever point it hits, and it's going to go right there. Because I could do the same thing. I could pick another point, I could make a tangent line there, then I could send my line from this focus to reflect off there. I do my reflection, reflect this line off the tangent line, boom, it goes there. So every sound wave that leaves B is going to travel to A no matter which direction it leaves you from. So that's what a whispering room is. There's one application of it. Another application of it, there is an electronic device that's used in medicine, and I don't remember what it's called right now. I guess I could look it up. But it uses sound waves to destroy like kidney stones. So what you do is you slide your body in to the object, and what happens is sound is emitted at a high frequency from this focus. Okay, and let's say a kidney stone was lined up perfectly at the other focus. That sound is going to, that high intensity sound is going to come and converge together on that kidney stone and can break it up. to dissolve it. Really kind of a neat feature, and it isn't going to harm your body really at other points because the sound's not focusing at another point in your body. It just focuses right there. Lastly, and I don't know if you've seen this before, there are some elliptical billiards tables, which is really cool because you have a point right here, okay, at one focus. You have the only hole in the billiard table at the other focus, and as long as you put the ball down right here, you can hit that ball wherever you want, and it's going to go in the hole every time. So I wanted to share those applications with you with that reflection. It's kind of a neat deal. Thanks for watching.